Thank you. How many of you have been using Cassandra or any distributed system in production for more than a year? Put your hand up and keep it up for a sec. Now, only keep your hand up if you have never had any kind of production issues or outage or anything. Hey, one person claiming? No? Yeah, all the hands go down. So distributed systems can be really complicated. There's a whole bunch of problems that can happen, and you can get kind of the unintuitive result that what should be a highly available system actually has lower availability in practice than a single machine server, just because of all the complicated things that can go on. Now, one of the things that I think can help improve this situation is if we talk about the mistakes that we've made and the problems that we've had, so that we can learn from each other and hopefully not keep on repeating these mistakes that other people have already made. Now, what I'm going to talk about today is 3 different outages that we've had, that PagerDuty has had with our production Cassandra cluster. If you don't know what PagerDuty does, our customers are mainly tech companies. They have a lot of different monitoring systems. When they detect a problem, like a server going down or high latency, they'll send an event to us, and then we do a whole bunch of processing, and then we call or text or email you to let you know what the problem was so that you can fix it quickly. Now, this part in the middle is where we care about high availability a lot, because if your stuff is going down, you want to be able to rely on us to stay up. So in the middle here, we have a whole bunch of different services. They are mainly using Cassandra and Zookeeper, running in multiple data centers. And actually, one of the fairly uncommon parts about our Cassandra setup is that we're running in multiple data centers, and we're doing quorum reads and writes, where our quorum actually goes across the wide area network with significant latency. A coworker of mine is giving a talk about some of the kind of cool things that happen when you have that kind of a setup tomorrow, so if you want to check it out. So the first outage I want to talk about, which I have ominously nicknamed the backlog. A bit of background about our cluster. We have a shared cluster, so all those arrows from the different services that we're pointing at one cluster, that is actually just one cluster, spread across multiple data centers, but still just one. And it's a fairly small cluster. We're talking low tens of gigs of data, and even more than that with our usage pattern. We tend to write a bit of stuff into Cassandra, and then pretty shortly after that, we'll process it, maybe a few seconds or a few minutes later, and then we're done with it. So in terms of the active data set, it's even smaller than that. It's more like tens or a few hundreds of megabytes. The first outage actually begins the day before we had some kind of warning signs. We had a few small degradations going on, and what triggered this was cron kicked off a repair process on our Cassandra cluster, and it caused a fair bit of load. We were seeing high latency from the application, and what we ended up doing to resolve this was disabling thrift on some of the nodes and turning some of them off. For us, we're still on the old thrift interface, so disabling thrift is forcing our application to use a different node for the coordinator. And by doing that, we can kind of push the load around a little bit, kind of shuffle it, and with that, we were able to recover somewhat. So what it looked like was we have a read latency, very, very low, what it should be, and then it spikes way up. And then we use these techniques of kind of disabling thrift, disabling nodes, shuffling around the load, and then it kind of improved. But we can't leave it like this because we have nodes turned off, and that will affect our availability. So we turn them back on, and then we had problems again. And then we turned them back off, and then it recovered. And so we kind of shifted around, and by the end of the night, it looked like this. This is over about a 6-hour period of kind of struggling to get our cluster recovered. Finally, at the end of this, we did have everything up, everything recovered, and we were pretty much okay. But the problem was that we had killed that repair process that had started this whole thing. And you need to do repairs fairly often on your cluster, otherwise you can have data coming back from the dead. So we had to actually do that repair again. So our plan was to get a bunch of people around to keep an eye on the cluster, trigger that repair, and hopefully be able to react really quickly if anything went wrong. And as I mentioned before, this was a shared cluster that all of our services were using, so we were able to turn off a couple of non-critical services to decrease the load a little bit. And our plan was to just use these strategies that we'd used the day before if things went wrong. But the problem was that when this happened, when we manually triggered this repair, what we didn't realize was that we had cron set up on that machine to trigger a repair on a different key space shortly after that. And then a little while after that, we also had a compaction that was triggered on one of our largest column families. We were using size-tiered compaction at the time, and we were running manual compactions. So all these things happened at once, and we got this. This is a graph of our outgoing notifications that we should be sending to our customers, and our backlog just keeps on growing and growing. And so we used the strategies that we'd come up with before. We were trying to push load around, get it to recover, but it just kept getting worse. You can see kind of almost a little bit of recovery in the middle. I'm not sure if that's actually real or just a blip, but gave us a bit of false hope there. And if you want to see what an unhealthy cluster looks like, by the way, we have lots of graphs of that. Here we have the read stage. This is when you are doing a read in Cassandra. It has a bunch of internal queues that things go through, and we can see here a growing backlog and kind of very unhealthy queue for this. Also, our CPU just looks terrible here. We're not quite pegged, but we're not really good. And so this went on for around 2 hours. And unlike the last outage, we didn't really have any recovery periods here. We just had, more and more of a backlog. So we were struggling, trying to figure out what to do. What we were doing before wasn't working. Eventually, what we kind of concluded we had to do was all the data that we had in our cluster is basically in-flight data. So it's not our real user data. It's just kind of things that we put in there that should be handled quickly. So we had an option, which was to delete all of our Cassandra data and bring up the cluster to recover it. And so we very, very quickly tried this out in our load test environment to make sure that we actually could do it. And in the meantime, tried to fix it. We couldn't fix it, so that's what we ended up doing. We kind of hit a factory reset button of just purging our Cassandra cluster. And I say, it kind of worked here. It did work, our cluster recovered, but you can't really call it a success because we deleted a bunch of data, which is not very good. But it did work-ish. After this, we did a ton of investigation into what went wrong. Now, in kind of a very selfish way, I'm just a tiny bit happy this happened because I got to spend a lot of time learning about Cassandra, figuring out what went on, learning about the internals. So the benefit from this is that a lot of people at the company learned a lot about Cassandra because of this. What we kept on trying to find during this was what were the leading indicators? What would have told us that things were going wrong? Because while the outage was going on, it was really clear that things were bad, but leading up to it, a lot of the metrics that we were looking at didn't really show that. So what we found was that we needed to put more effort into looking at the Cassandra-specific metrics. We were looking at mainly host-level metrics like CPU, network, that kind of thing, and those were fine almost all the time right up until you actually have an outage, so it didn't really tell you anything. The Cassandra metrics, though, I'll talk a little bit more about what we found there after. What we ended up concluding from this was basically that our cluster was just underpowered, mainly in CPU. During normal usage, when we had our regular requests, things were fine, but when you have repairs and compactions going on a somewhat growing data set, it was just too much, and we were on 2 core machines and in this shared cluster, so it ended up kind of overwhelming the cluster. Another one, kind of a specific one to our use case, but we did a lot of operations that at the beginning you kind of needed a whole bunch of operations in a row to succeed before you could do other work. And so if your cluster is unhealthy and even a small percentage of operations are failing, that whole sequence fails and then you can do basically nothing rather than doing a little bit of work. Some of the lessons that we learned from this first one. The big one was capacity planning. This was just an oversight on our part. We had what we thought was a fairly small amount of data. We thought the cluster could handle it, so we weren't really paying attention to capacity planning, but we should have. The other one is that we added a lot of Cassandra-specific monitoring. So Cassandra exposes a lot of metrics through JMX, and we were actually collecting them, but we didn't have them on easy-to-use dashboards. So we put a lot of work into that. The other really big thing that we learned from this was more isolation is good. We had all these different services hitting one cluster, and it made it really hard during the outage and after the outage to figure out what was going on. Was it, which service was causing the load? Was it in Cassandra? It just makes it really tough to figure out. And it also means that when it fails, everything fails rather than having just some things fail. Some of the metrics that we found, I won't go over all of them. I'll just mention probably the most important one is the dropped messages one. This one is Cassandra's sign that it's overloaded. So when it gets a request and it can't handle it in time, it will drop that message and record it in a metric. And we weren't paying attention to that, but that would have shown in advance that our cluster was becoming overloaded. All right, now a completely different outage, unrelated to the first one at all. We had made some improvements since the last outage. One of the big ones was isolation, what I mentioned before. And we did this, a live migration of all of our services to have their own independent cluster. And we actually did this for not just Cassandra, but for Zookeeper as well. And I have a ton of stories I can tell about that, but the short version is that isolation pays off there as well. Even though it should be highly available, there are lots of problems where it might not be. We also added a new service, which is what this outage is about. And the last one, we bumped up our Cassandra version. It's a little bit embarrassing how old of a version we were on, so I'll just tell you the version that we went to, which is we upgraded to version 1.2. So we were a bit old at the time, actually still now. So what happened with this new service was we needed to add a bit of data and have it wired through a few different column families. So we did our schema migration on our cluster, and then we did a deploy to actually use that, and we started getting a few errors recorded in the application. This invalid request exception telling us also what key space and column family had problems. So we immediately checked our Cassandra danger metrics dashboard. This is actually our real name for it too. Since the last outage, we made a dashboard which is lots of different metrics which can be a sign that Cassandra either is overloaded or is having problems. But in this case, it was clear. But from the exception before, we knew that it was something schema related. So we ended up running describe cluster through the CLI, and we saw this output, which shows us the problem. Every node here is on one version of the schema, except for one, which is on some other version. So we know we need to take some action against that node, but we're trying to figure out what to do. And the solution ends up being turn the node on and off. And then once you do that, everything is fine. This is what the output should look like. Everything on one line, meaning that all of the hosts are on the same Cassandra version. So at this point, we haven't really had an outage. We had a few errors, but with retries, all of the tasks we were doing were successful. And it was fine for a couple of hours. And then we get this. This is the outgoing notifications for PagerDuty, where everything is fine for a while, and then it drops off to nearly nothing. So checking our Cassandra, what we saw also in the application was really high latency to Cassandra. Should be low, spiking up to much, much higher than it should be. Checking the Cassandra danger metrics page, this time we do find something, which is the mutation stage. This is similar to the read stage I showed earlier, but this is for write operations that are going on in the cluster. It should be basically how many are queued up, and it should be basically nothing, but instead one host goes off on its own and has a ton of operations that are backing up. So we know we need to do something. In this case, we immediately disable thrift on that node to prevent the application from using it. A little while later, we notice that we have a repair process running, and so we kill that. And shortly after that, we just kill the node completely. And that ends up working for us. This is how many operations we were able to perform on our cluster. Now, the cool thing about what we did before was that there ended up being a bit of a gap in between each operation that we did. So zooming in on this graph, we can see what the effect of each individual operation was. When we do that, we see that first we disable thrift, and then immediately everything recovers. So the other actions that we took didn't actually fix it. It was only disabling thrift that fixed it. Now, disabling thrift is just forcing our application to not use that node as a coordinator. So the question we have is, why did just one bad node have such a big effect on our latency that it basically caused our application to not be able to process anything at all? There's another small puzzle here of why did the application keep on using a bad coordinator, and I do have the answer for that, but I don't have time to go into it, but just trust me that we do know what went on there. But with this, we only had this one node that was being bad, but overall, our operations were taking much, much longer than they should have been. And the answer to this turns out to be fairly straightforward. What you need to know is that our average request time for a successful operation is about 25 milliseconds. But the timeout in the client we had set to 10 seconds. And 10 seconds doesn't seem that long in human terms, but when you compare it to how long a good request should have taken, you have this giant multiplier of a bad request, or a request sent to a bad node takes 400 times longer than one sent to a good node. So even though, and keep in mind we had a fairly small cluster, so even though only some of the operations are going to a bad node, it doesn't take a very large percentage for you to have a really high multiplier of how long your average requests will take, given that some of them are going to a bad node. Now, there's also the question of what happened to Cassandra. We know kind of, given that Cassandra was acting up, why other things went wrong. But the question of what happened to Cassandra, for that, we don't really know. We do have some theories. Yeah, some people are laughing who recognize the picture. We do have some theories, but we don't have any actual reproducible things that we found, at least not yet. Now, some of the lessons that we learned. One of the big ones is that we got some payoff from this isolation. We had problems with our cluster, but it only affected one service. Now, because our services kind of form a pipeline where you need all of the ones in the chain to work, it did still cause notifications to be delayed, but it meant that all the requests from our clients coming in, they could just be queued up, and it would just happen a little bit later rather than being dropped on the floor. We also learned how we should be doing schema changes, which is you do describe cluster, make sure everything looks good, run the schema change for one column family, and then do describe cluster at the end to verify that everything actually went okay. And we even added a bit of monitoring for this schema disagreement too. All right, the third outage. This one is particularly painful. This one had the lowest impact on our customers, but it was pretty directly caused by me. So what happened with this one was we were scaling out one of our Cassandra clusters. We'd been adding nodes. After they were added, you run repair on them, and then they're good. We had added a new node. We ran repair. And then after a couple of hours, we noticed that nothing was happening on the node. Cassandra wasn't logging anything out. It wasn't having any network traffic. So we restarted that node. And just to be safe, we did a slow rolling restart across all of the nodes in our cluster. And partway through doing that, we got this, a giant spike of latency to Cassandra. So checking our danger metrics page, it was unfortunately clear. What we ended up having to do was pour through the logs of Cassandra and find this info level log that one of the hosts was doing hinted handoff. It was trying to replay the hints to another node, and it did do some of them successfully, but partway through it failed. Hinted handoff, by the way, is when you know that you want to write something to another node, but you've either tried and failed, or you think that the node is down, so you don't even bother trying at all, you write a hint locally, and then you replay it later. So this replaying, we replay some of them, but not all of them. Now, to get our cluster back into a healthy state, what we ended up doing was picking that host, which seemed to be having problems, killing it, and then everything recovered. And then we waited for a little while. After things were good, we brought that node back up again, and then everything was bad again. So we quickly shut it down. And we actually, we were curious to see if it was just a coincidence that it happened after we brought it back up. So we brought it up another time. And then things started going bad, so we killed it and said, okay, clearly something is wrong with this node. So we started investigating. And we found something strange. In the commit log directory of Cassandra, we saw a couple of files that were owned by root. And these were actually from about a month before the outage. They were really old files. And so after a bit of digging, we found a couple of commands that were run around the time those files were created by me. I had run this sstable to JSON command as root on our machines, and it ended up creating these files. Now, a quick detour into sstable to JSON. If you don't know what this is, it's a really cool command where you can look at kind of the low-level details of what Cassandra has stored on disk in the sstable. And it's really cool, and I was trying to run it in our low-test environment even before the month before the outage. And if you've never done this before, what happens when you first run it is you get an exception. Some partitioner doesn't match this other thing, and so you look for a while, you try to find, is there another argument I'm supposed to pass to this to tell it what partitioner to use? After giving up on that and just searching, you find a bunch of unhelpful advice telling you to delete files and other stuff, and eventually you find what works, which is you need to set an environment variable to tell the tool where to find your config file for the partitioner that it needs to use. So after you've done that, you get another exception. And at this point, you're just thinking, like, come on, I just want this thing to work. I don't care about permission errors, just to run. So you run it as root, and then it works. And this is in low test, by the way, not production. But the problem here is that this sstable to JSON command has a bug in it. It was reported after the outage, where it will write commit log segments. This happens because the sstable to JSON command actually lives in the same jar as the rest of the Cassandra code, and so it manages to accidentally call the commit log code and write out a commit log segment. And if you run it as root, you get a commit log segment as root. So we have a commit log segment written as root. What's the problem here? Well, the problem is that Cassandra will try to recycle commit log segments. That is, rather than creating a new one and then deleting the old one, it will rename the old one to the new file name that it wants and then truncate the file and try to do that. So if you try to do that, then you get a permission problem. But the other part here is this was a very delayed effect. I had run this command a month before, and it wasn't until we restarted the process that this happened. And the reason here is because Cassandra will only reuse the commit log segment for the files that it knows about. So because it was written by another tool, it didn't know about it until you restart the process. Then it will read in all the files from the file system and then try to reuse them later on after it's filled up. So that's why we also get the kind of some of the hints go through, but then after the commit log segment fills up, then nothing else can go through. And so this is the whole chain that breaks. You have a mutation stage, which is just a write in Cassandra. And to do that, it has to add something to the commit log. To add it to the commit log, if it runs out of space in the current one, it has to fetch a new segment. And the code that is populating new segments failed a while ago with an IO exception trying to rename this file, which was owned by root. So with that, what we have are the lessons from this outage, which is you need to be careful about what habits you develop. I think this was particularly hard because there's a delayed effect of you run something in low test and it works there, and you kind of build up this habit of doing it a certain way, just run it by root and everything is fine. But if I was to run it in production the first time, I wouldn't have just done that. I would have looked more carefully, switched to the Cassandra user probably, but I built up this habit before. The other part is that some discussion that went on in the ticket for the sstable to JSON command is that they should have had the command be more isolated. It was able to do that, writing the commit log segment, because it just kind of happened to call that code because it lived there. But instead, it should have been completely isolated. And if it was, nobody would have written, commit log segment writing code for a tool that is supposed to be just reading a data file. The last one, I think the most general one, is that anytime you have rarely run code, like process startup code, you can have these delayed effects where you do an action and it's not until much later that you feel the consequences of it, like some kind of failure. We've had other problems like this too, where we change a config file, but then we haven't restarted the process that read that config file, and it's not until you do that that you find out that whatever change you made to the config file broke something. So one of the things that I'm happy about with these outages, at least the trend here, is that they seem to be getting less severe. The first one was really terrible, and these are in chronological order, by the way. So we had a really terrible outage. Second one, bad, but not quite so bad. Third one, we're even faster at fixing them. And I think that the main reason why that has happened is because we put so much time into investigating these problems when they happen. We put in a lot of effort into figuring out what actually went wrong. In some cases, like in outage 2, we don't get the full answer, but we at least try as much as we can. And so that's what I want to leave you with. It's that whenever you have these kinds of outages, you should put in as much time as you can reasonably manage to put in to figure out what actually went wrong. And ideally, share these mistakes with other people, even if they're really simple things like permission problems or really complicated things. It just helps everybody to learn from each other's mistakes and improve. Thank you.
Questions for our speaker? Not all at once. Don't be shy.
Hi. The particular metrics you chose as your sort of leading danger indicators, after using them for a year, do you still think those particular ones are the useful indicators, or are you sort of looking for better ones?
The dropped metrics one certainly is a good leading indicator. Blocked flushed writers, at least in the case that we saw, it was a good indicator. That can also happen for a few other reasons. But I still think it is kind of generally pretty good. GC behavior, it's a bit hard to read, so it's kind of hard to tell. And the lagging ones that I gave, those are still quite valid, but they are lagging indicators. They just tell you when something is already wrong.
Do you guys use PagerDuty to alert yourselves?
Do we use PagerDuty to alert ourselves? We actually do. So for most of the problems that we have, the vast majority of them, we're actually still up. We just notice kind of weird problems, and so we can still use our own application to alert us. We do have a couple of backup ones that we use just in case, if we have something that actually causes all alerts not to be able to go out, or the account that we're using for ourselves not to be able to go out.
Hi, I saw in a config file that you are using the property file snitch. Are you still doing that?
Sorry, could you repeat that?
I saw in the config file you were using the property file snitch. Are you still using that one?
Yep, I believe we are.
I recommend changing it to gossip file snitch unless you want a fourth outage.
So which one, sorry?
The gossip property file snitch rather than just the property file snitch. That one has bitten us in the past more than once.
Nested property? Okay, let's talk after. I'm curious what problems you've had with it.
Reproduce any of the problems?
Could you repeat the question?
Yeah, sure. Were you able to take, can you hear me okay? Were you able to take any of these files offline and reproduce any of these problems in test environments or do analysis in separate environments rather than in production?
Yeah, we often do try to reproduce these problems in our load test environment. Usually we don't have to bring data over. We did that when we were expanding our cluster to make sure that when we were adding nodes that nothing went wrong. We've heard about problems with that happening in the past. For most of these, they weren't really data related though. The permission problem, we've been able to reproduce pretty easily. We've also been able to reproduce a lot of schema disagreement problems that we've had just by adding packet loss.
Okay, thanks.
Question way back here.
Hi, here, this way. First of all, thank you for the nice, sharing your nice experiences for the last 1 year, the failures in the Cassandra. Those are very good. Thank you. And we had gone through the similar things. But I wanted to understand more about the danger metrics that you guys are using. Which tool that you are using? May I know that?
You wanted to understand more about which one? Sorry.
The tool, like,
The SS stable to JSON tool?
no, the danger metrics UI tool. You are using some UI to view the metrics, right? Danger metrics.
Oh, the tool for the metrics that we were using.
Yeah.
For that, we use Datadog. It's a hosted version of a StatsD provider.
Oh, okay. Thank you.
Yep.
Yeah, so you mentioned that process startup can be like a very rare process. So in the spirit of if it hurts, do it more, like have you guys ever considered running restarts on your clusters continually? And if so, like did that help reduce those types of errors and issues, or?
Have we thought about doing restarts right? What I would worry about that is that we would be masking other issues. I think that kind of the ideal solution is anytime you have one-time process startup code, you should also write some other code that monitors for whatever condition is there and almost do it continually. So in the case of config files, rather than reading it once and then using it, maybe sure you only read it once, but you should also have monitoring that if it changes, you should get alerted, and so you should take some action based on that. But interesting idea.
Yeah, hi. I am not entirely sure I caught this correctly, but at one point you said that after expanding a cluster, you ran a repair.
Yeah.
Okay. Could you please elaborate a bit on why did you do that? Like why do you did a repair after expanding a cluster?
Why did we run a repair after expanding the cluster? I don't remember the exact reason. I think it might be just to make sure that there's no data missing while you were being added to the cluster, but I'm not sure.
In the back. Coming.
So how does schema disagreement occur?
How does schema disagreement occur? Bugs, I believe. It should never actually occur. We are using 1.2, and I've heard that it's better in 2.0, but at least in 1.2, you can quite easily cause schema disagreement by adding some packet loss to a node and then doing a few schema changes. And after a little while, you'll see that the cluster disagrees. It's not something that is supposed to happen, though.
Anybody else? Let's give our speaker a round of applause. Thank you very much.
Thank you.